Okay, for this video, we'll be going through your notes, success criteria E. So there are some questions that by right you should attempt before watching this video. Okay, so E1 figure below shows a refrigerator. Okay, the fridge walls are made of smooth white metal. So when we talk about smooth, we think about radiation, right? We link it to the concept of radiation. White as well. When we talk about metal, it is about conduction, right? And a solid. Okay, so with a layer of polystyrene foam is actually a non-metal. It is a solid. So polystyrene foam, maybe you would think of it like styrofoam, so it's very light. Why? Because there are air particles or air molecules in between. Okay, so why do they use metal? Because metal is very durable, right? But in between, take note that the polystyrene foam is in between this layer of metal. Okay, so which is in between the inside and outside walls. So now describe how polystyrene foam insulates the refrigerator. So now in the fridge it is cold, and of course external it will be warm, right? That's why we put things in the fridge to cool them down. So how does this polystyrene foam insulates the refrigerator? Okay, so the polystyrene foam actually traps large amount of air in individual relative tiny pockets, right? So since these tiny pockets of air prevents transfer of heat by convection current, okay, so the air can only transfer heat through or thermal energy through conduction. But because both air and polystyrene are poor thermal conductor, this insulates the refrigerator from gaining thermal energy from the surrounding. Okay, so we talk about both conduction and convection because there are many tiny air particles in there. Okay, so the air may heat up, but because they are separated into many multiple air particles, right? So convection is not able to be done as compared to if I have a lot of large air pocket. Okay, the large air pocket will result in convection current, but over here the air pockets are very small. Okay, and plus the fact that air and polystyrene, they are poor thermal conductors. Therefore, it will insulate the fridge from gaining thermal energy from the surrounding. Okay, so this one is more of conduction. Part B, explain how the cooling unit at the top cools all the contents of the refrigerator. So this is actually about convection. Okay, so let's see how do we answer. Okay, so for this, since it's about convection, we'll talk about VDACC. So this is our answering template. V stands for volume, D stands for density, A is the action, C, the first C is compare, the second one is convection current. Okay, so when at a cooling unit, and near cooling unit gets cooled and contract. Okay, so this is our V. Okay, density of cool air will increase. So this is talking about our density, right? Then the action, so the cool air will sink. So this is the action, followed by warmer air from the surrounding will rise and take the place of the sinking cold air. Okay, this sets up the difference in densities, sets up a convection current. Okay, so this is our compare, then followed by the conclusion, setting up a convection current, which will then cool down all the contents of the refrigerator. Okay, part C, the inside wall radiates a small amount of thermal energy, infrared radiation. State how the color affects the amount of energy radiated. So as the name or the question already says, talk about radiation. So then you must ask yourself, where is it hotter? The walls will definitely be hotter than the content. Okay, so here will be hot, right? Because it is in contact with the outer surrounding. So within the fridge, confirm is cold. So these actually are white color. So white is a poor. The fact is, white is a poor emitter and absorber. Now you have to ask yourself, where is it hotter? The wall is hotter, right? So do you want the wall to emit thermal energy to the content inside the fridge? Answer is no, right? That's why you use a fridge. So white is a poor absorber of thermal. Sorry, should be a white is a poor emitter of thermal radiation. Okay, so it will reduce the rate of radiation to the content in the fridge. Okay, yeah. Okay, let's go to E2. E2 figure shows ice in a plastic bag being carried by a nurse. So ice is definitely cold. Okay, from a freezer to the operating theater in a hospital. The bag is held at rest and a convection current forms in the air outside the bag. Okay, but they want us to draw an arrow to show the movement of the air at X close to the bag. At X, the air is cold. Air is cold. So when air is cold, the volume will decrease, it will contract, density will increase, so action will be sink. Okay, so just draw a vertical. So if you draw things like, let's say this is X, yeah, and then you draw things like that, okay, it is wrong. You just draw a vertical arrow down because they just want the movement of air at X. Explain how the convection current is formed. So when the air is cold, you use your VDACC. Okay, so you can refer to the previous question. It is the same answering format. Okay, the nurse noticed that the ice melts too quickly. She puts the plastic bag containing the ice into a second plastic bag. There's a layer of air. So what does this layer of air do? Air is a poor conductor. Okay, so let's see how we can answer, yeah. Okay, air is a poor conductor of heat or good insulator, right? So with the layer of trapped air, it will reduce the thermal energy that's conducted to the air inside the first layer of plastic bag. And also, we were talking about convection here, right? Using VDACC. So basically, if this is the plastic, then the ice is here, the air will actually go down, and then rising hot air from the surrounding will come out to take the place, right? And then this sets out a convection current. However, now if let's say I have a plastic bag, so the air is actually trapped, although there may be some convection current but not much because of the air being trapped. So that's why I included the second answer. If the air is trapped, it also reduces the possibility of airflow in convection current to form convection current. That's why it's 2 marks. Okay, so let's look at the third question. Figure shows a computer chip that is fitted with a heat sink with black metal fins. So black, you think of radiation. Metal, you think of conduction. Now how about the fins? If you look at the diagram, the fins actually increase surface area, right? It increases surface area in contact with air. And also, for fin, I would think of it as convection, right? Because versus a heat sink with solid plates, no gaps, okay, no gaps, solid plate, the air that passes through, there will be minimum air passing through. But now with gaps, the air can actually pass through, and if the hot air rises, it will increase the rate of convection current being formed. Okay, so for this question is quite common. They will have radiation, conduction, and convection. So you need to recognize the keywords. Okay, so the computer chip is actually the one that is hot. Okay, and because this heat sink is in contact, therefore I will need it to be metal so that it can conduct away the energy. So please do not use absorb, because now metal, we always talk about conduction. They are touching, it is conduction, right? Heatsink keeps the computer chip cool. The thermal energy is transferred away by conduction, convection, and radiation. Explain the difference between conduction and convection. So this is basically a definition question. Let's see how we can answer. Okay, conduction is the transfer of thermal energy due to the collision or vibration of the particles. There's no movement of the medium in the conduction, right? But convection is the transfer of thermal energy due to the movement of the medium itself and happens only in fluid. So that is the difference, right? Or you can use the definition that is for conduction and convection, right? And that will actually state the difference using the definition. Now explain the features of the heatsink that allow thermal energy to be transferred easily away from the chip. I don't want the chip to be heated up, so I use the heatsink. And this is 3 marks. So of course we must talk about conduction, convection, and radiation. Alright, so we can have all 3 processes. Let's take a look at the answers now. Okay, thermal energy from the computer chip is conducted away by the heatsink, which is made of metal, and it is a good conductor of heat. Now, when it is in contact, we use conduction. Okay, try not to use absorption. Then we move on to maybe radiation, as black is a good emitter of thermal radiation. Now that the heatsink is hot, okay, because it was in contact with the computer chip, it is hot, so we want it to be emitting thermal radiation. That's why we use black color, because black is a good absorber and emitter. But we will focus only on emitting, because the surrounding will be cooler, right? When you play games, when you use your PLD, the computer chip becomes hot, right? And the heatsink will also become hot due to contact with it by conduction. Yes, so now the black being a good emitter, okay, we do not use absorber here because now we want it to emit, so we leave out the absorption. So we say black is a good emitter of thermal radiation. Therefore, the thermal energy that's transferred to the heatsink can be emitted away quickly. Okay, then the design of the heatsink increases its surface area, which aids thermal radiation, right? As surface area increases, the rate of thermal radiation also increases. Then in addition, the vertical fins allow for the movement of air around the heatsink, right? Which allows convection currents to be set up. Because basically my fins here, my air passes through, it will rise. Then I will have more air pull in, and this will set up a convection current. Okay? Yep. Okay, so that's all for the video.